All right, so polynomial division. Let's start with some review of some stuff we've done before. So 6x to the fourth minus 15x to the third plus 3x squared over 3x squared. So if we were going to simplify this, the way we'd done that before is we took 6x to the fourth and just made 3x squared the denominator. Same thing for the next piece and then the last piece. And then we simplified each of those fractions out of that. So simplifying using exponent rules and just regular fraction stuff that we knew about before. So same idea here. If we're dividing by a monomial, that's what we can do. That's the simplest way of doing that problem. So the first term simplifies to be what? 2x squared. Good job. The second term minus 5x, and then the last term would be plus 1. So that's wonderful. If you're dividing by a monomial, that's definitely a possibility. If you're dividing by a binomial, that is not quite as easy. And some of you may have done some of this in Algebra 1. You may not have. It's not. If you didn't, it's okay. If you did, great. You may not remember it. Okay, so one of the things that you can do here when you've got a division problem, it's written as a fraction, but we know fractions are just division symbols. We could try to factor the numerator and see if it matches up with the denominator and cancel out. That would be an option here, and that's what we're going to try first with this. Is there anything, if we're going to factor that top part, it's trinomial, so multiply by 10, add to be -7. What does that? Yeah, -5, -2, those do work. I can take the shortcut, so it'd be w minus 2, w minus 5 on the top, and the bottom is still w minus 5. What happens to the w minus 5s? They can cancel out just like the 6 and the 3 on the first problem did. So that numerator factored, and we were able to cancel out a matching factor so that the final answer is just w minus 2. So that simplifying a fraction there is really what we're doing. We're using factoring to help us do that. And that's great as long as it factors. Let's look at another one of those real quick. Maybe written in a different way. 4x squared minus 7x minus 2 divided by x minus 2. So this one's written a little bit differently, but it's the same kind of problem as number 2. It's written in just regular old elementary school division problems kind of style. Okay, so the same idea here. If you got this division problem, you want to look to see the quick, efficient way. Remember, one of the things that we try to do in Algebra 2 is get faster at doing some of the things that we already knew how to do. So when we're doing division, one of the quickest ways to divide is like we did number 2 with the factoring idea. So we want to look at that first polynomial and see if we can factor it, because this is our dividend, what we're dividing into. We want to see if it has the factor that's our divisor, what we're dividing by. Okay, so if we can factor this, it makes that division a lot easier. And if you want to write it as a fraction so that it kind of helps you look at that, that's fine. So we know we're going to have x minus 2 on the bottom. Let's see if we can factor that numerator. So I'm going to do the x method on that because it's a trinomial. -8 and 7 to -8 and 1. And can I do the shortcut though? No. So over here I'm going to do the factoring by grouping that I've got to do. And then I'll put that in the numerator over there. So it's 4x, x minus 2, plus 1, x minus 2. So our factors are x minus 2 and 4x plus 1. And that's great because now we see, hey, we got a matching factor, and they cancel like that. So the final answer would just be 4x plus 1 out of that. So when factoring is an option, then hey, use that. It's going to make life easier out of that. But we always are going to encounter problems that factoring doesn't work with. We did that with quadratics, and we had to use the quadratic formula. When we did higher degree polynomials, there were times we go. There were times where we couldn't factor a trinomial that was left in there and still had to do quadratic formula. So there's times where the polynomials are not going to factor. So when factoring is not an option, what do you do? Okay, so one method is long division. Look at that. In long division, we're going to take this example 4 x squared plus 3x minus 43 divided by x plus 8. You remember doing this some when I was born? Yeah. It's not the funnest thing in the world. So, but I'm going to show you a couple of different things today. So long division is reason we would look at this. We know it doesn't factor because there's nothing that multiplies to be negative 43 and adds to be 3. So your first option when you're getting problems like this and trying to simplify or divide them is think factoring and try to do that. Especially if it's a trinomial, that's a lot easier to do and quicker. But there's 43 is a prime number, so the only things that multiply be it are 43 and 1, and so there's no way that that's 3. So we know that won't factor. So long division is what I'm going to show you first, and then I'm going to show you this thing called synthetic division. It's pretty cool. So long division, we're going to set it up old elementary school style. The divisor goes on the outside, and long division symbol, x squared plus 3x minus 43 on the inside. So that's been a while since you've done that. All right. Now, the way that you do polynomial long division is you want to make sure that you've got a representative from every power of x, starting with the highest one. Okay. So we got x squared, so that means we need a representative for x squared. We got to have a representative for plane x. So if plane x wasn't in there, you have to put a 0x in its place. Okay. So you got to have that in descending order and have a representative for every power. This one has one. It has an x squared. It has a 3x. And then it's got an x with a 0 exponent on there. So that's all 3 of the things we need. On the divisor, the same thing. The highest power on the divisor is 1. We've got x to the first power and then a plane number. So make sure those things are there. If they're not, you've got to put a 0 in their place. Okay. All right. Now the next thing you do is you look at the first terms of each piece. First term of the divisor is x. The first term of your dividend is x squared. What times x would give me x squared? X. So that's going to go up top. And I'm going to put it over the x stuff. 99.9% of your problems with long division can be fixed if you will organize your work. Most people that struggle with long division are people that don't organize their work well. So if you'll organize it, notice how I've got kind of 3 columns here. I got an x squared, I got a plain x, got a plain number column. So what times x gives me x squared? That's x. I'm going to put it over the plain x column. If you'll organize yourself, it'll really help you a lot. The next thing we do, remember when we were doing long division and we divided like 3 into 47 or something like that? And, 3 went into 4 one time. What did we do with that 1 and that 3? Multiplied it and then subtracted, right? The same thing happens with polynomial division. Take this x and multiply it to the x plus 8. So x times x, that's x squared. X times plus 8 would be plus 8x. And then we're going to subtract that whole thing. And x squareds cancel out. That should happen every time that you're doing that. And then 3x minus 8x would be negative 5x. And bring down the minus 43. On a regular number problem, we subtracted that, got a 1, and we bring down the 7. Same rules as doing long division for numbers. The next thing we do is look at the first terms. X and negative 5x is now my first term. What times x gives me negative 5x? Negative 5. So I'm going to put a minus 5 up there.
Minus 5 and that's come back that negative and it's going to be.
But I'm going to subtract.
Okay,
so it's going to cancel out. Yeah. So Negative 5 goes up here. I'm putting it over the minus 43 because it's a plain number. So negative 5 times x would be negative 5x. Negative 5 times positive 8 is negative 40. Parentheses, subtract. Negative 5 minus negative 5 cancels out. Negative 43 minus negative 40. Negative 3. All right. Once I get there, is there anything times x that will give me a plain negative 3? No. So that means I'm done. Okay. The degree of what's left here is smaller than the degree of my divisor. So I know I'm finished. What is the negative 3? The remainder. Okay. So this is your remainder. All right. And the way we're going to write our solution is like this. We're going to say x minus 5 plus negative 3 over x plus 8. The remainder over the divisor as a fraction. That's how we're going to write our solutions to this. If there is a remainder. If the remainder is 0, then you don't have anything to write there. Okay. Be honest. Long division stinks. Okay.
I understand normal long division. I don't understand.
Polynomial long division is a little tough. It's got all those x's and things in there. It'd be a lot easier if you didn't have the variables, right? Yeah, you had to do a lot of back and forth, right? So if the variables wasn't in there, it'd be a lot easier. So that's where synthetic division comes in. So I want to show you synthetic division. It is. Emily, of course you'd say that. All right. Synthetic division is a lot easier. Let's take the same problem. Let's take that x squared plus 3x minus 43 divided by x plus 8. And we're going to set up and do synthetic division. I'm going to show you how to do that. So I'm pretty sure nobody in here has done synthetic division before. So what you want to do is take I'm using notebook paper, so just 2 lines, and make yourself kind of this laying down L. Okay. And then put your little shelf out here on the side. All right. Now, the way synthetic division works is it takes the variables out of it for us to do our division part, and then we'll put them back at the end. Okay. So on the inside here, the top row, there's going to be 2 rows in there. So the top row is going to be the coefficients of your dividend, what you're dividing into. So the coefficients, you got to have a representative from every power of x, starting with the biggest one. Same rule. So what's the coefficient of x squared? 1. What's the coefficient of x? And the coefficient of x to the 0? Negative 43. All right, so that gets you the top row. Now, we got to have a number on the shelf. Okay? To get the number on the shelf, you take your divisor, what you're dividing by, and you set it equal to 0. So it'd be x equals negative 8. This is what goes on the shelf, negative 8. Okay? Now, here's your first step. Every single time with synthetic division is drop the first number down to the bottom. All the way. It's kind of like when you go to play, y'all don't play video games, right? At the arcade or anything. If you do, you've got to put the coin in the slot, right, and let it get started. That's how you start the game. That's how you start the game with synthetic division. Drop the first one down. It's like dropping the quarter, getting the machine to start working. Now, multiply. 1 times negative 8 is negative 8, and it goes right there. Always add. That's the next rule. So 3 plus negative 8, negative 5. Then we multiply again. Negative 5 times negative 8, 40. Add. -3. Now, let's put the x's back in there. What we've got now, we started with x squared. We did synthetic division by something that had a single x. X squared divided by x is x. So our new first term is a plain x, 1x. Or just x minus 5, no x's on it. What's that number right there? That's the remainder that we saw when we did long division. So that'd be plus -3 or x plus 8. You'll change your mind eventually.
What about whenever we start getting through the cube?
Good question. We'll get there.
So can we do this for everything?
All right, here's the good question. Tucker says, when can we do this synthetic division for everything? No. The only time that you can use synthetic division is when your divisor is linear. What does it mean for the divisor to be linear?
It can't have an x squared.
Can't have an x squared or an x cubed or an x to the fourth. Its degree has to be 1, just a plain x, all right? So synthetic division works as long as what you're dividing by is linear. Yes, but the rest of the time doesn't come up. Hey, here's the thing. The rest of the time doesn't come up that often. The synthetic division is going to come up more often. You're going to be able to do it more often than you are the long division, okay? Long division is something we'll need really as a skill for when we do rational functions. That comes up a lot more then. But when we're solving polynomials, which is what we're going to take this and use tomorrow for, synthetic division is really going to be your tool. That's going to be the thing that you use to kind of break down a polynomial that won't factor. All right. So let's do another quadratic one, and then we'll get into a cubic one. Caleb asked about a cubic one. So let's do a quadratic one here. All right. So set it up with our it's strange. It gets more familiar. Oh gosh, don't design any buildings I go in. Gosh. 2, -16, 19. What goes on the shelf? +7. Where does that come from again? Set the n plus 7 equal to 0. Solve it. Okay, and that gets you the number on the shelf. Drop the quarter in the slot. 14. Then what? That'd be -2 times 7. 5. So what's our quotient and remainder? 2n minus 2. That's okay.
Plus 5 over n minus 7.
Good job. Not bad, is it? A new skill we're learning today, and we're going to use it tomorrow to really do some stuff with. All right, so let's go a little bigger. So this is where it really gets real. You got a bigger polynomial. That polynomial, the dividend has 4 terms. You would normally try to factor that by what? Grouping. And if I can see that right now, if I try to group the first 2 together, it's going to have x plus 5 left in it, and this is no way that's happening here. Right? So we can see that factoring doesn't work on that. So long or synthetic division is the best way to go here. So I'm going to use synthetic because I'm dividing by a linear divisor. Okay, it's much quicker, a lot less multiplying going on. if you do long division with that, you got a lot of operations going on. There's significantly less with synthetic. So what goes on the shelf? 2. What's our coefficients? All right. Drop the 1. Bless you. 2, and then 7. It's going to give you positive 7. Positive 16. What is that 16? That's the remainder. Okay, so now what's our quotient? Remember, quotient means the answer to a yeah. That's it. Getting pretty good. All right, so when you do synthetic division, you're using a linear factor, so it's always going to take your degree and do what of the original problem? Reduce it by 1. Okay, so anytime we've got a synthetic division operation happening, it reduces our degree of our dividend by 1 every time. So our quotient's always 1 less. Let's look at a couple more. X cubed minus 17x plus 32 is divided by x plus 5. Okay? Yeah, so when I set up my synthetic division for this, I'm going to have a 1x cubed, a 0x squared, negative 17x, and 32. Got to put that 0 in the place of the missing term. Negative 5 on the shelf there. Drop the 1, multiply. 1 times negative 5 is negative 5. Add, that'd be negative 5. Negative 5 times negative 5 is positive 25. And positive 25 and negative 17 added together is 8 positive. Multiply, negative 40. And negative 8, what is the negative 8? It's our remainder. So what's our quotient? Goes down 1, so x cubed goes down to x squared, so minus 5x plus 8 plus negative 8 over
Okay, we're gonna have to keep the variables the same because I'm trying to run in right now, so we gotta keep it.
Oh, just pay attention. Always adding on the inside of the synthetic division. It's always add. No, E has a meaning, so we can't use it. It's like I. It has meaning. Yeah. All right. No.
No, the A doesn't.
That's a different E. There's been worse on it. All right. So we got 8x to the 4th minus 64x cubed plus 3x minus 28. It's all divided by x minus 8.
So can we do that synthetic thing?
You tell me, Kim.
Yeah.
What's the rule that decides if you can? The divisor is linear. That's what it's got to be, okay? So, set it up. Degree of 1 on the divisor. That's what it is. Can't do synthetic if it's a quadratic. Anything bigger than plain X.
Oh. Okay, serious question.
Okay.
Got a lot of zeros? What? Yeah, I got a zero, it canceled out, so put a zero down.
All right, so let's catch up. Let us catch up to you. So 8 on the shelf, 8, negative 64, 0, 3, negative 28. Right? All right, so drop the 8, multiply. And there's a 0. So 0 times 8 is 0. So that's going to give us 0 there. 0 times 8 is still 0. And that's going to give us 3. And that's going to give us 24. And so negative 4 would be our remainder there. So what's the degree of our quotient? Cubed, because we started with fourth and we did synthetic division, so it goes down 1. So that's 8x to the third plus 0x squared plus 0x plus 3 plus negative 4 over x minus 8.
If you don't put the 0.
What do you mean?
Like,
Oh, it won't work. It doesn't work out at all. Like you won't get the correct remainder. Your quotient will be messed up too. All right, let's do one more. Sure, we'll do another one. Uh-oh. Uh-oh. Can we do synthetic with this one? Yes, I can, because 6x minus 3 is linear. That's mx plus b, right? That's linear. It's the degree of 1. So the divisor. That's okay. It's still a number, though. No, I promise it would not be. You wanna latch onto this synthetic division. You're good.
I really did not like
I'm sorry. All right, so we got 6x minus 3. When you solve that, you're going to get x equals 1/2. So 1/2 goes on the shelf, and it's okay to divide. Here's the thing that we're going to see in the next day or so. As we go into this a little further, we're going to be taking a polynomial and trying to find its zeros, like what we've done with factoring and all those things. And sometimes that's a fraction, sometimes it's a complex number. The beautiful thing about synthetic division is that it works no matter what kind of number you put on the shelf. And you can do that with that because you can relate those zeros to linear factors and go from there. So let's do this one. 1/2 of 18, 9, it'll be negative 9. Negative 9 times 1/2. Negative 9 over 2. We don't do decimals in this class.
That's just how I know what it is.
We know 10 is negative 20 over 2. So that'd be negative 29 over 2. There's our remainder. Our remainder is that ugly fraction thing. That's okay. So what's our quotient, though? Not bad. Not bad.
Yeah, that was in the long division.
Long division would have gotten us the same exact answer. No matter if you do long division or synthetic division, it gets you the same answer. Let's do one more long division problem. I'll go and let the cat out of the bag here. Well, maybe this will help. The only way to understand is do it more. No. Why is this one a long division problem?
Because it's 3x squared.
Yeah, our divisor is not linear. It's quadratic in this case. The dividend is cubic. So on the outside, we got the 3x squared minus 3x minus 6. On the inside, what do we have? 3x cubed plus 0x squared minus 6 plus 13. Again, putting that 0 in the place is going to help keep you organized. Now, with long division, you always just look at the first terms. What times 3x squared gets me 3x cubed? X. So that's going to go up here above the 6x. And then what do we do with that x? Multiply it all the way out to the divisor. So distributive property there. So that's 3x cubed minus 3x squared minus 6x. Divide or subtract. All right. So the x cubes cancel. And then you're going to have a positive 3x squared. Yeah, so that's really plus 0x and plus 13. So I dropped down the plus 13. That's where that came from. All right, so what times 3x squared gets me 3x squared? Positive 1. So plus 1 up there on the top. Distribute. That's easy. Always remember your parentheses, subtract. Bless you. That cancels out. Positive 3x plus 19. Now, can I divide any further?
No.
Yeah, that's my remainder because the degree of it is smaller than my divisor. Our divisor was x squared. That's a plain x. I'm done. So x plus 1 plus 3x plus 19 over 3x squared minus 3x minus 6. So with long division is wonderful and it works. But look how many operations you got to do. You got to do 1, 2, 3, 4, 5, 6 just for the first step. And then you got to bring this down, and then you got to do 1, 2, 3, 4, 5, 6. So there's 12 so far. And then get the final thing here and see if it goes again. So 12 steps where synthetic division is never that long. So a lot of steps in long division, okay? So synthetic division is going to be the one you're going to use the most often, okay? For everything we're doing in here for polynomials, we're going to use synthetic division the most, but that doesn't mean it's the only way to do it. Long division does work, but it's long division. It's in the name. You don't want, it takes forever to do that. So, all right.